Part C. Well, in this question, we're told that in a storm, the total volume in centimeters cubed of rainwater that enters a gutter can be modeled by the function R of t, where t is the time in seconds since the start of the storm. And then we're not given the function R of t, but we're given the derivative of R of t. So we're told that the rate at which rainwater enter the gutter is modeled by R dash equals to 50 times cosine of 2 pi t over 5 plus 3000. So this is the derivative of R, and we're told that in any 60-second period, if the volume of the water entering the gutter is greater than the volume of the gutter, it will overflow. And then in part C, we have to determine whether the gutter will overflow. Well, first off, what is the volume of the gutter? In part B, we found the area of the cross section of the gutter. So we were given this diagram of the cross section of the gutter, and we found that the area of this is 294 centimeters squared. And so what's the total volume? Well, in any prism-like shape, the volume is simply the area of the cross section times its length. So we have here the original diagram. This is the shape of the gutter. The cross-sectional area, so over here, this is 294, and its length is 600. So the total volume is simply going to be 294 times 600. So volume of gutter, so volume, cross-sectional area, 294. And if we want to be more precise, 294.43 times the length. So I'm just going to say A for area times length, A for cross-sectional area times length. So 294.43 times 600. And this is going to be equal to, well, I have here that 294 times 43. So times 294.43 times 600. And we get 17,600 and, 176,658. 176,658. And depending on how much precision we use for the cross-sectional area, we could get something slightly different. But that's the total volume, more or less. And how much water is going to enter the gutter in this 60-second period? So we have the rate at which the water enters the gutter. So the total amount of water in the gutter is going to be, during those 60 seconds, is going to be the integral from 0 to 60 of the rate at which the water enters the gutter. So the integral from 0 to 60 of r dash of t dt. So basically the integral from 0 to 60 of 50 cosine 2 pi t over 5 plus 3000 dt. And then we can find this with the calculator. So let's go to our calculator. We go to math, go here to the right, and we see the integral sign. So let's input our derivative function here. So 50 cosine of 2 pi t over 5 plus 3000. So 50, do this in parentheses, cosine parentheses, and we'll use x in place of t. So 2 pi x divided by 5 plus 3000. And then we input our limits. So we're going from 0 to 60. And we get exactly 18,000. So the total amount of water that's going to enter the gutter during those 60 seconds is exactly, not 18,000, excuse me, 180,000. One more zero, 180,000. So we're going to have 180,000 centimeters cubed of water that's going to enter the gutter during those 60 seconds, which is more than the volume of the gutter. So 180,000 is greater than volume of the gutter, which is 176,658. So we have more water entering the gutter in the 60-second interval than the volume of the gutter, so the gutter will overflow. Gutter will overflow. So that's the answer to part C.